Good afternoon, everyone, and welcome to the webinar on the Climate Risk and Resilience Scorecard. My name is Claudia Gonella, and I'm the Marketing and Communications Director here at GRESB, and it's a pleasure to record and host this webinar. We've got two main speakers for the webinar, and we'll be sort of handing over the reins backwards and forwards. Can you just move the slide, Rick? Thank you. So here in the Amsterdam office next to me, we have Rick Record, an associate on the real estate team here at GRESB.
Thank you, Claudia.
And Rick has been very involved in the development of the scorecard. And calling in from Geneva, I believe, we have James Lockhart-Smith from Verisk Maplecroft. Hi, James, can you hear us?
Hi, Claudia. Yes, loud and clear. Thanks for having me.
Great. And James is the head of financial sector risk at Maplecroft and has been working very closely with us on the scorecard. So we're in good hands. So what we're going to cover on this webinar is we're going to kick off with James giving us a brief introduction to Verisk Maplecroft for the people who are listening who don't know very much about the organization. Rick from GRESB will then position the scorecard in relation to our work on physical and transition risks related to climate change, and also how that fits within the TCFD recommendations. James will then talk in more detail about the risk data sets that made up part of the methodology here, and also actually go into the detail of the methodology itself and the mapping with asset level data and asset data in the GRESB data set. Rick, I think you'll then dig into the scorecard itself and talk through the charts and tables. We'll conclude, and then we have some questions, and we'll be going over those and responding to those at the end. So I think, James, it's over to you with an introduction into Verisk Maplecroft.
Brilliant. Thank you very much, Claudia. Well, just very quickly, as Maplecroft, we have existed for almost 20 years. We were acquired by Verisk at the end of 2014. Over the last decade, we have evolved into a data analytics and research firm, and our goal is to provide actionable intelligence on around 160 ESG, climate, political, and economic risks across 198 countries, and for some of those risks across 74 industries and around 160 hard and soft commodities. Our focus is very much geography or place-based risk. So what is the risk to an investor or a corporate or an asset because of the country or place that they are in some way exposed to or associated with? The one thing we don't do is corporate ESG performance. So instead we map country ESG factors to various different kind of asset classes. As Maplecroft, we have a total staff of over 100 people with around 60 deep domain experts based all over the world. We have offices in the Americas, in Europe, and in Asia. Our investor clients really use us for a mix of risk management and generating alpha in some cases, and we work with a number of asset owners and many asset managers. And as part of all of that, we do work on real assets in general, and then real estate in particular within that, and that's the focus of our collaboration with GRESB. And it's been a great pleasure to develop that partnership with GRESB over the last 2 years and see it culminate in this scorecard.
Thank you, James. So moving onwards to GRESB and the TCFD recommendations. Annually, GRESB conducts a survey amongst its GRESB investor members to see what the top ESG issues will be in the next 5 to 10 years' time. And over the past 2 years, what came out on top was climate change, resilience and adaptation, and TCFD implementation. This coincided with when our collaboration with Verisk Maplecroft started, to really see how we could map or provide insights to GRESB participating portfolios by combining our data sets with external data sources to showcase insights without additional reporting burden. So quite early onwards, our collaboration really focused on climate change and TCFD recommendations, but further to that, we saw that there was actually a very broad range of overlap between our data sets. So specifically on TCFD recommendations, the TCFD recommendations cover a wide array of disclosure requirements related to governance, strategy, risk management, and metrics and targets. And what kind of can be reported under TCFD is something that we are currently capturing in the GRESB Resilience module, which is a voluntary supplement to the GRESB Real Estate and Infrastructure Assessment. But in this framework, we look more at what companies can report on, and we try to highlight best practices rather than really contribute to new insights other than benchmarking. As you can see here, we see that how participants respond to the resilience module can also be mapped against the TCFD recommendations in different categories. And we see that a small number of resilience module participants is able to report quite well on this TCFD recommendations. They have good governance in place. They cover a lot of different elements with their risk assessment. But there is a very large group of this self-selected universe, because the resilience module is voluntary, that currently does not really appear to have a structured risk management process in place, and probably isn't really aware of what kind of risks are most material to them, at least from a global perspective. So when you think about climate change risk, and this graph comes from the TCFD, there's sort of a trade-off. You can have high physical risks. Already we see physical risks all across the world in terms of flooding, in terms of very cold winters or very cold summers. But this is likely a risk that is going to increase, particularly in a scenario where governmental action on climate change is limited. And in another scenario, you have high transition risk, where government action is very immediate and strong, which results in increasingly stringent regulation, potentially hurting asset values and contributing to stranded assets. Note that this graph can also be a little deceiving here, as it might let people assume that there's an optimal way forward here, which will lead to the least amount of risk, the least amount of physical risk in relation to transition risk. But most scientists are actually quite convinced that a high transition risk scenario is, for most portfolios, a better solution in the longer term. So when it comes to transition risk, GRESB is currently really collaborating with the Carbon Risk Real Estate Monitor project, which this webinar is not about, but I can recommend you to look into if you're interested in this, in which we develop sectoral decarbonization pathways with a group of research universities that really look at the asset level of what the transition risk is of different real estate portfolios across the world. But to also cover this other part, this physical climate change risk, we see that a geographical analysis is very important. And for that, we geocoded our assets and mapped it against Verisk Maplecroft subnational environmental and climate change risk indices. And basically, this collaboration led to the development of a new scorecard in which we geocoded our assets. We looked at the GRESB data that was already there, and we created 24 newly established adaptation indicators from that, which have subsequently been mapped against 44 Verisk Maplecroft Risk Indices. As James will explain after this, we put a lot of effort into defining a relationship between risk and adaptation. So what this scorecard shows is, on the one hand, your risk exposure, but also it showcases opportunities of how you can increase portfolio level resilience, and how you perform on this in comparison to your peers. So I'm now handing it over to James.
Brilliant. Thanks very much, Rick. So I'll try and keep it relatively fast moving, but first of all, I'll just try and explain a little bit more about what our data is, and then go into a little more depth on how the data fitted into the scorecard, and what the analytics behind the scorecard actually are. So yeah, as I said, at Maplecroft, our focus is very much geographical or place-based risk. We see ourselves as sort of bringing an extra dimension to ESG analytics. Obviously, traditionally, the focus has been on how entities manage risk, i.e. performance management disclosure. There are two other key dimensions though. So what does an entity do? So industry and technology. We touch on that obviously, but then the main area where we come in is where is an asset? What is its sort of operational context? We'll talk a little bit more about why that's important a little later on, but think of it as being to do with risk exposure. So we apply this across a range of different asset classes. If we could go on to the next slide, please. Although we have data sets on industry and commodity, our country data at national and subnational levels is really at the heart of everything. And we sit at the center of an ecosystem of different types of data that we collect and analyze. I think it's sensible to start at the level of, as it were, the sub indicator, which is the sort of the basic building block of all of our indices. We have around 850 of those at the moment. Those are coming from 4 general kinds of source at a high level. So most important in the environmental space is geospatial or remote sensor data, especially from satellites. The most traditional type of data source, which we still use to some extent, is structured third-party data. So that would be a CSV, for example, an Excel file from an intergovernmental organization. And that's very familiar to people looking to do ESG integration of different sorts. We use this particularly in the economic domain and a few social risks, but as time has gone on and our data coverage has expanded, it's arguably become less important in comparison to others. And the 2 other types of data source are unstructured and proprietary. So unstructured data is essentially textual data that's not structured, that's out there primarily in open sources, where we then apply machine learning, artificial intelligence to derive scores. And this is particularly important in the domain of different kinds of human and labor rights risks. Now, we actually introduced that to try and make our process more resource efficient, to free up our analysts for other tasks, but we actually found that the outputs were more reliable than arguably more subjective human analysts. And then the last kind of category of data is proprietary data sets that we develop internally ourselves, because there are no external data sources that we think are entirely appropriate for what we're trying to cover. So that's very important in the domain of governance, political risk, and actually corruption as well, when you want to look at the structural underpinnings of corruption and outcomes rather than perceptions by themselves. So yes, we have hundreds and hundreds of underlying sub-indicators feeding into our indices. If you could move on to the next slide, please. That then results in around about 160 different indices. So an index is a kind of composite view on a particular risk or phenomenon. All of the indicators have been through a particular transformation process which reflects the structure of the data and a range of other considerations. And the idea is that you then get a robust view on how risk compares in a particular place or country to other areas in the world. Now, in terms of domains, these cover political risk, economics, as we said, human rights, environmental, and then some specialist areas as well on things like financial crime, as well as some new, more forward-looking models which we have developed. So all of that means we have around 30 human rights indices, about 40 political risk indices, and over 50 environmental and natural hazard indices, and the majority of those are subnational. So if you could go on to the next slide, please. Yeah, I mean, data is always going to be imperfect, but it's also always essential for a range of purposes, particularly sort of risk-based prioritization. It could be informing investment decision-making processes. It really depends on the individual investor. But just delving into the environmental indices a little more, you can see some of these pulled out here. In the subnational ones, we're really varying between pixels of 22 kilometers squared and down to 0.2 kilometers squared. It really depends exactly what we're covering. And then we have a group of physical climate change risks where we are looking really under representative concentration pathway 8.5 at mid-century time period. So that's both for the key sort of climate change exposure index, which is the most important of these, and then other related indices like heat stress, which measures sort of wet bulb temperatures, which are dangerous to human health, for example. So yeah, we go very, very local and very granular with these environmental and natural hazard indices, and all of this gets fed into the scorecard. So if you could move on to the next slide, please. Yes, so then thinking a little bit more about how we have applied this in the context of the scorecard, we felt looking at environmental data in this way was particularly important. It's obviously more material for real estate as an asset class than perhaps it is for some other asset classes. We're dealing with typically long-term time horizons where assets are quite sensitive to risks which could manifest in the very long term, be on the wrong end of abrupt repricings when risks actually manifest. You're dealing with pretty exposed ownership for general partners. The sort of the ethical and the reputational onus is very much on the manager. There's no corporate to take responsibility. There's generally a need for sort of in-depth due diligence, especially once you move out of public markets. And then there's actually more visibility into geographical exposure than you would have with other asset classes, certainly at the end investor level. And then, ESG management solutions can also be at the local level as well. And I think that's really reflected in GRESB's shift towards asset level data collection in the recent past. And then, yeah, there's also a considerable need for sort of management mitigations of geographically related risks, because there's perhaps less latitude for moving somewhere else. An asset is obviously fixed, and then in terms of options within a particular country, sort of the opportunity landscape will often be quite concentrated within a few places which have given risk profiles. So, we're talking about risk exposure. It's kind of obvious why that's important in the world of natural hazards and physical climate change, because an asset is exposed to physical climate change, it's exposed to a natural hazard. But what about ESG? This is really because, in our view, geography and sort of the geographic context and risk context shapes the nature of the positive or negative external impacts that an asset might have on society and the environment. So a good simple example here would be if you have an asset with high levels of water consumption, it's more likely to have an unsustainable impact on the environment or cause competitive conflict with other local water users if there is more local water stress versus water abundance. And you could say the same about a number of, in fact, all ESG risks, and actually including carbon emissions as well, because of the role of national regulation in shaping transition risks. So what all of that means is that you can and you should be able to calibrate management demands to underlying risk exposure in order to make sort of apples to apples comparisons between different funds when you're benchmarking. It's not really fair to hold two funds to the same standard on a highly specific issue if one is very exposed and the other isn't. So, you know, capital allocation and the focus of management attention really needs to be guided by risk exposure. So that's sort of been the principle that's informed our collaboration with GRESB. If you could move on to the next slide, please. Great. So as Rick said, we mapped the Maplecroft dataset to the GRESB dataset. You have the 24 GRESB categories, which Rick described on the left, and then you have the 44 Maplecroft risk indices on the right. So we've taken a sort of fairly expansive view of materiality across E, S, and G, which, you know, does reflect the predominance of environmental risk, but doesn't leave out social and governance risk either. So think of this as two very, very comprehensive sort of orthogonal data sets coming together. GRESB, which has a lot of portfolio level information, but increasingly asset level data as well. And then that is pretty much all geolocated either locally at the asset level or at least in terms of a breakdown of gross asset value if it's a portfolio level. And that means that it can be paired up with our own geographical risk data sets. And you know, hopefully you can see from this mapping just how many issues we have in common. The idea was to match up risks with specific management actions and policies designed to address them. And even those kinds of risks which might, on the face of it, seem less important to developed market focused real estate portfolios are still actually more relevant than one might think. So, for example, considerations like forced labor or modern slavery are important once you begin to look at supply chain and service provider relationships. And so once we've got these two data sets combined, we have a unique opportunity to move from just looking at management alone to being able to benchmark and analyze ESG management and climate management as adjusted by underlying risk exposure. So if we could move on to the next slide, please. Yeah, so just a little word about the role of asset level data in the data set. This is really important. So there's around 67,000 assets in the GRESB data set already, and that's growing rapidly year on year as participants transition into portfolio and asset level reporting. So remember that many of the Verisk Maplecroft climate and environmental risks are being measured at a highly local level, also that many hazards are very place specific and are only going to affect a minority of properties. And just how specific some of those hazards could be, you know, you will see in cases like, for example, coastal flood and tsunami hazard on the right of this plot, which, you know, are very serious for properties that they affect, but only affect a minority of properties. However, we've set the scorecard up to effectively prioritize whatever physical hazards are most relevant in a particular place. So we look at the worst of the scores across the sort of natural hazard risk profile of a particular asset. And then GRESB has a management metric which is looking at management attention on multiple natural hazards and therefore covers all of those. And so we're looking at sort of the worst of the natural hazards versus, you know, the level of management attention. So it will basically look at whatever is most important for a particular asset. And you know, despite the specificity of some hazards, others are universally important and going to become more so. So if you look at the left of this plot, this is just standard box and whiskers notation, by the way, with quartiles and minimums and maximums. You can see that some of these hazards are really extremely important for the majority of assets in the data set. So look at water stress, for example, or even more so heating degree days, future climate, which is looking at the impact of climate on the energy demands for heating buildings. Severe storm also very, very important there, or air quality. So these are issues which are important for almost everybody, not just a minority of assets. So moving on to the next slide, please. So how did we actually go about risk adjusting for underlying risk exposure? So we developed the concept of what we call sort of the adequacy threshold. Just a side note here, as Maplecroft, we actually haven't had access to the raw location data of GRESB participants in order to protect data confidentiality. So the way it's worked is we have shared our own geographical data files with GRESB, who've done the geocoding themselves, and then we at Maplecroft have been able to analyze anonymized data sets. So here you see on the scatter plot a practical example of what matching on sort of risk-adjusted management adequacy actually looks like. So this is the management of physical climate risk on the x-axis compared to, sorry, I apologize, the risk exposure on the x-axis versus management on the y-axis. So as I said, this is our climate change exposure index, which is looking at sort of RCP 8.5 out to mid-century at a very local level. And then you can see all of the GRESB assets plotted on both of these dimensions. So it would be compellingly simple to just draw a 45-degree line up the middle of this plot and say, well, as your risk exposure increases, so should your management attention. That would be simple, but it would also be misleading because we're dealing with a lot of different kinds of risks where the relevance of geography varies a lot. So the key innovation of this data set is to come up with the concept of thresholds for adequacy that vary by issue. So we went through an expert-led process between GRESB and ourselves, deeply informed by the way we were scoring the different data sets to come up with these thresholds. So what we're asking is, at what point are we prepared to say that a specific level of management which comes out of the GRESB scoring is adequate to a given level of risk which comes out of our scoring. So some are linear, some are more stepped. It really depends on what the risk is and then how the scores have been developed and aggregated and transformed on both sides. But what you get to is a way of making fair comparison between different funds with very different levels of risk exposure. So what we do is measure where they sit relative to that adequacy threshold across each risk and management pairing. And once you've done this across all relevant ESG issues, you can provide very, very targeted recommendations to general partners about their level of risk and what they can actually do in terms of management actions on the GRESB side to improve their score and actually their sort of fundamental resilience. So if you could move on to the next slide, please. Just very quickly looking at a slightly different risk issue here. This is corruption rather than physical climate risk. The conclusion of our process here was actually that safeguards against corruption should be extremely strong almost everywhere, regardless of the degree of local risk. So the y-intercept, if you will, on the left is actually very high, but the same principle remains. So how does this then feed into the scorecard? If you could move on to the next slide, please. Yeah, so as I said, across each risk and management pairing, we have measured distance above or below that adequacy line. And then we're actually able to aggregate all of those up. So the scorecard will show you average risk exposure, average adaptation scores, but then it will also provide an aggregate, which is in terms of percentiles, where we have taken an aggregate of distance from the adequacy line, and then we have compared the fund in terms of its percentile to the overall universe. And you can see how that works on these example scatter plots across everything, and then across E and across S and across G. So yes, risk-adjusted management benchmarking is what the scorecard is all about. And I'm going to hand back to Rick at this point to just run through the features of the key features of the scorecard itself.
Great, thank you, James. So on the scorecard itself, the first page really provides a high-level overview of the key risk and aggregate risks that are most important to an entity, as well as aggregate GRESB adaptation scores. So what you see here is the aggregate score overview. You see on the most left-hand column, the Verisk Maplecroft Exposure Score. These risk scores are sometimes based upon the actual assets, sometimes based upon GAF contributions in a specific country related to the risk. It's really showcase in aggregate what the average risk score is of the entity overall in terms of environment, in terms of social, in terms of governance. The weighting that is used here is available on the next page. We'll discuss that in a bit. Then you have the GRESB Adaptation Score. This really is more of a regular GRESB score, similar to scores in the GRESB Real Estate Assessment, based upon newly created indicators that use existing GRESB variables from the 2019 GRESB assessments as their inputs. We'll discuss that towards the end of the scorecards. And then you have the risk management score. And the risk management score is a percentile ranking based upon how well a company's adaptation score is in comparison to its risk exposure score based upon the adequacy level, which James just explained. So it also displays what the scores are of the global GRESB average, as well as the peers of the entity itself. Then you have a very quick top 5 ESG and climate risk overview. This really displays the top risks according to the Verisk Maplecroft dataset. But it also displays how the entity's risk relates to the GRESB average risk score. So just to highlight, these are fictional numbers, but in this specific instance, the average GRESB water stress score would be 8.9. And we see this as important because Verisk Maplecroft takes a global perspective for attributing risk scores, but GRESB participating portfolios have a strong bias, I would say, to developed markets and then specifically major commercial centers. So a significant percentage of our GRESB assets are located in London or New York, for example. Then you have an aggregate universe model overview. This is really to showcase how the entity does in aggregate based upon adaptation and versus risk. So it displays all the entities in the GRESB universe and how the entity scores there compared to other assets. It's very important to highlight that these are aggregate risk scores, and underneath it there might be specific risks to an entity that might be extremely high, or even specific risk to a specific asset in an entity's portfolio. So we're really talking about aggregates here. Then we have a small section on reporting characteristics. This is exactly the same as is being displayed in the 2019 GRESB Real Estate Assessment Benchmark Report. It's really there to be informative to investors, to really be a reminder of which peers the scorecard refers to, which type of peer group, and just as a way to contextualize the data. Then I have an exposure to physical climate risk and natural hazards overview. This is based upon a simple count by the number of assets that are exposed. So it categorizes assets in whether they have extreme risk, high risk, medium risk, or low risk. Next, we have the mapping overview. This mapping overview provides an overview of the individual risk scores that are attributed to a portfolio. Also, how this is being weighted upwards towards overall risk scores. It displays the GRESB Adaptation Indicator, what the GRESB Adaptation Indicator score is. It also displays, based upon this level of risk, what the adequate adaptation level would be, and also based upon a traffic light system, whether the entity meets that level or is slightly underneath it or well underneath it. So if it surpasses the adequate adaptation level, this kind of traffic light system here is displayed in green. If it is less than 2.5 points below the adequate adaptation level, it's displayed in yellow, and if it's more, it's displayed in red. And that means that it is very strongly suggested that the entity would implement more adaptation measures to deal with that specific risk. And what kind of measures we suggest are displayed towards the end of the scorecard. Then on the third page, there's an overview of the top 10 assets based upon floor area, and it shows all the physical climate risk and natural hazards risks for those top 10 assets. And again, it uses the same risk classification system to showcase which assets for which specific risks might be extremely high, for example. So as you can see here, we see that the distribution center at Servatistraat 65 is an extremely high seismic hazard risk. As mentioned, all of these numbers are fictional here in the example. Then we move over to the GRESB adaptation level, or the GRESB adaptation indicator overview. Participants of the GRESB real estate assessment can see that all of these measures are taken from different indicators of the assessment. And we use a relatively simple scoring mechanism to establish these GRESB adaptation indicators. So for every type of measure, there's a relevance, whether it's high, medium, or low. If a measure is rated as high, it has a weight of 1. If it is rated as medium, it's weighted as 0.5. And if it's rated as low, it's weighted as 0.3. And all of this is aggregated based upon either in place, not in place multiplier, or in some instances, we also look at validation decisions or the percentage of portfolio covered, and we use that as a multiplier there. And all of this contributes to the adaptation indicator score displayed in the mapping. So the moment you see that there is either a red traffic light or a yellow traffic light highlighted for a specific risk, you can go to this overview and see whether there are specific instances where a measure is not in place. And by in next year assessment, ensuring that this is in place, your adaptation indicator score will go up. So you get a higher overall score. Now, moving onwards to the key takeaways from the scorecard and this analysis, we'd say that really important geography matters. So ESG, climate, and risk exposures really differ widely across portfolios and between assets. So geography really can be seen as a materiality assessment that can be used to enrich the GRESB real estate assessment data set. Next to that, because geography matters, prioritization also matters. So the scorecard can really help companies with highlighting which risks are most important to them, also in relation to their peers or the wider GRESB benchmark. And this can help in prioritizing policies and different measures that help mitigate those risks. At the same time, we also see that both water stress and future heating degree days are some of the most pressing issues currently faced by participating GRESB real estate assessment portfolios. Finally, acting, of course, is very important after prioritizing. So the GRESB real estate assessment really covers already a wealth of information about how to improve upon the resilience of your portfolio, mostly at the managerial level. And finally, benchmarking is very important. So through comparisons against peers and the overall GRESB benchmark, you have a further understanding of what truly is important. So as you also already saw, the GRESB benchmark has really a specific characteristic of being located in developed markets. So the risks you face are different compared to the global risk of, for example, flooding, which is something that Maplecroft looks at. Now, on the next step and what we've done so far, so the initial mapping that we concluded was already done in 2018. We launched the scorecard about a month ago. Now we're really looking at feedback to reiterate the scorecard and incorporate further feedback to make this scorecard even more useful for you. And through that, we also hope to make the scorecard available to limited partners. So right now, we only sell the scorecard to participating real estate portfolios, but we believe that especially LPs are currently at a disadvantage in that they don't know what truly the risks are within their portfolio, because they don't have access, a good understanding of local issues, because quite often their exposure is global. So now I'm handing it over to Claudia that has some questions submitted by participants of the webinar.
Thank you. And yeah, Rick, great presentation. And James also, thank you for your presentation and for going into the detail. So yeah, we have several questions that have come in. Some go into the detail of the methodology, and we also have a couple on the sort of accessibility of the scorecard. So I think we can dive right in. So James, I'm looking at this first question, and I think it's really for you. It's a question on the water data that you covered earlier in the presentation. So here's the question. In the water stress example, does the index incorporate multiple factors? For example, does it incorporate population density and the volume of freshwater reservoirs?
That's a great question. So there's a supply side and a demand side to water stress, because, you know, water stress is essentially looking at the ratio of the two, you know, of one to the other. So on the demand side, we are using a combination of national, economic, and then sort of subnational satellite data to model or observe everything we can about human activity and economic activity within particular places in the country. So we're looking at a sort of subcatchment level, really, at agricultural, residential. So subcatchment means within a watershed. Looking at agricultural, residential, and industrial water demand of different kinds. On the supply side, our criterion is renewable water resources. So we're looking at rainfall, and we're looking at rivers from rainfall. by extension, we are also looking at rainfall that then flows into reservoirs. Probably the one key exclusion is aquifers, so because we don't consider those renewable. So if you're in a particular place and by draining aquifers faster than they can be replenished, then that might work in the short term, but it's not sustainable. So we exclude that from consideration. We're not looking at sort of accumulated stores in reservoirs that might be highly relevant for particular cities, for example. I think our model would probably be the starting point for more in-depth scrutiny of water management in a particular city or place. Is this London or New York, or is it Cape Town, for example, or Mexico City in terms of how they manage water?
Excellent, thank you, James. Rick, I think this is a good question for you because it's on the availability of the scorecard. The question is the scorecard only available for 2019, or could it be developed quickly for earlier years? And the example here is from 2010 to 2018.
Yeah, so that's a very good question. I would say it cannot be developed very quickly for earlier years. So because we base this upon asset level data, what is very important for us is the information provided in the address fields. And that was truly accurate and designed for this in 2019. In 2018, we have relatively good data as well, but it's not as good as in 2019. And before that, the address field was less important and not necessarily required. What we can calculate relatively quickly is adaptation scores for earlier years. So if there's a specific demand for that, we could look into that, but not the entire scorecard, not the risk scores. Okay,
makes sense. Thanks, Rick. James, I'm seeing a series of quite detailed methodology questions here for you. So I'll get started with the first. And the question is, could you confirm that all of the indicators, with the exception of those that say future climate, are based on historical data?
So the natural hazard and environmental data that is not future climate is, yes, it's really based on models which are sort of looking at the last, for example, 20 to 30 years in terms of the more sort of atemporal hazards, and then obviously much more recent sort of annual reporting periods, for example, for some of the other environmental factors. So yes, our climate change indicators are obviously inherently forward-looking. The hazard indices are, in many cases, effectively atemporal. And then some of the other environmental models have sort of, reporting sort of periods that inform the analysis from the very recent past.
Okay, great. Excellent. Thanks, James. Question here on the climate risk indices. Are they based on the country in which the asset is located and not the specific address? So are they based on country or the specific address?
So on the physical risk side, they're all based on the specific address. So coordinates which come from the GRESB system then get matched to pixels, which are mostly, as I said, 22 kilometers squared. So that's about 5 by 5 kilometers, or could be as little as 0.2 relating to a particular address. The exception would be some of the things on the transition side, around carbon emissions, carbon policy. I think we have a couple of factors in there around waste management and recycling, for example. So those would be national level. But on the physical side and on the ecosystem resource side, so things like water stress, biodiversity, and so on, that is all very, very local level.
Great, thank you. A couple more questions here for you, James, I think. Here's one. The heating degree days and the cooling degree day indicators are for future climate, but what RCP is being used for that?
For consistency's sake, it's also RCP 8.5, like the Climatic Change Exposure Index. So basically RCP 8.5 is kind of the business as usual scenario. And then we sort of focused on mid-century there so that it's sort of near enough to be relevant and largely before the different scenarios have diverged. And I have to say, unfortunately, on the basis of current evidence, we do seem to be still stuck in very much in a sort of business as usual situation. So perhaps RCP 8.5 is quite accurate.
Okay, sort of related question. What specific physical risks does the climate change exposure indicator include? And a kind of, the question goes on, how does the RCP 8.5 pathway, how is that used to model these future risks? And I've got another question linked to this, and what is meant by onshore here? Are you okay to tackle all of those at the same time?
Yeah, sure. I mean, onshore means onshore, right? So it means we've just looked at terrestrial pixels within a particular country, and then you've obviously got the subnational scores which relate to those areas on land, and then the national score is a kind of aggregate of means and extremes at the country level. In terms of specific physical risks, about 40% of the index comes from this sort of bundle of hydrometeorological risks that we cover separately as well. So things like landslides, tropical storms, extratropical storms, drought, flood, coastal flood, things like that. So that's about 40%. And then we have the remaining 60%. We're using RCP 8.5 in a sort of ensemble model type approach to look at changes in climate extremes. So what do climate models say about the expected intensity or frequency of kind of extreme weather events like droughts or heat waves or extreme storms, so on and so forth. Then variability, which is sort of really interannual, I should say. So year to year, what the models say about how much climate will vary in particular locations in terms of, for example, the standard deviation of mean temperatures. And then lastly, changes in sort of climate means. So these are the what you would expect in terms of temperature, precipitation, and then sea level. So all of that, obviously there are major caveats behind any sort of composite climate change index, which is, analyzing these things using a sort of global approach rather than a sort of local systems dynamics approach. But I think we think we've got pretty close in terms of doing that robustly.
Great, thank you, James. I can see a couple more questions, and these are mainly related to the availability of the scorecard. So Rick, I'll send these your way. The first question is, here it is. I understand the asset level data is used to build the risk scorecards portfolio view, but if I buy a scorecard, can I see asset level risk, for example, in a map format or perhaps as a table?
So currently, this is only displayed for the top 10 assets based upon floor area. So this is what was included in the scorecard. Also to keep the price of the scorecard consistent across entities. We are exploring options to enrich our asset portal with additional risks there. But that's not currently included in this product offering.
Okay, excellent. And one last question. When will the scorecard be available and how quickly can it be delivered once purchased?
So it's already available, and after you purchase it, we aim to deliver it in 2 days' time. So we need to generate it on our end, but this can already be done, and it is all there.
Great, excellent. And there's more detail on the GRESB website on this, and yeah, please do get in touch if you have any more questions. And we'd also be happy to direct questions to Verisk Maplecroft or reach out to James directly. So James, thank you very much for presenting here with us. And Rick, thank you also to you, and thank you to all listeners. We appreciate the opportunity to present this work to you. Thanks very much.
Thank you.
Thanks.